Hello everybody, it's William. Welcome to my channel. So if you're new here, this channel is all about game development, about app development, about incorporation of artificial intelligence, and you're watching a serious video about a project that starts with a joke, with annoying complaint about the with a complaint about annoying ad that a lot of fake game ad that does not give you the result, and then I think of a llama and let's create a llama app, and then I think when the midjourney does not generate a top-down bird view llama, I got this 16 and 9 scrollable working, and then here we are now. We got a llama actually working, and we got one enemy. The rest of enemy, and still making all that. They generate a lot of good enemies, sprite shit for me, and I haven't got enough time to actually to do that. I just got a one coyotes, and it's working, and we got our llama working. Okay, so if you up, down, left, and right, you can actually see my llama is moving, but when you say you got a llama up and you just completely move out from the view, as you guys can see, this is a game view, but right here your llama is just at the top of here, and then your llama go down. That's not exactly what I want. So what I'm trying to do is to make this llama sort of can't go out from the view. So what I'm going to do is to get a really powerful built-in thing into work, which means that I'm going to restore the movement of this llama. Let me change it a little. Restore the movement of this llama to this camera's viewport. So let me bring my pen here so you guys can actually see what's going on. So screen brush. So basically this is our viewport, and we got this 0.0 relatively, of course. So there will be a so it's the x-axis. You can sort of think of this x-axis, and this will be our y-axis. Okay, so the x-axis will be just a 1, 0. Okay, so if you are here, you add the 0 but 1. Okay, and relatively this will be 1, 1. Okay, so essentially you are dealing with the area here, and adding places on this whole canvas doesn't matter, because we can leave computer to calculate that. The only thing we need to know is that as long as you got the camera viewport working, you can transfer that viewport to a world point automatically. You don't need to worry about that. The only thing that you need to remember is this number, 1 and 1. If this is 2D view, we got a vector. We got vector 2, which means that we got an x and we got a y, right? And the x will be the minimum will be 0 and all the way to 1, and the y will be minimum to 0 all the way to y, all the way to 1. So the top one is 1, 1. You can't exceed that. Okay, and I'm going to use this as a boundary mechanism, so our llama can't move outside of the boundary. So what I'm going to do is to go back to I think I got this llama script, llama prefab script, and inside the script we'll get a player control.cs, and let's write some C#. So we got update, move, and we got delta. So this will render the move frame irrelevant, and then let's add in a boundary here. So what I'm going to do is to get a void, and that will be our bound. So boundaries. Okay, boundaries. Okay, that's a pretty good name. Okay, let me see. This suggests vector 3 with the viewport position, word to viewport, transform position, and x climb to the x, y climb to the y. That does not give me a really good explanation. So I'm going to write a few code myself, so it can give Copilot a hint. So first, I'm going to get the main camera here. So I'm going to get the camera, right? Camera dot main camera. All right. So we got the camera main. That will be our main camera, and you can access this main camera because the boundary is set by the main camera. So main camera dot screen to world view. But in fact, this counter is a word is a viewport to word points. So not so what I'm going to do is to dots viewport to word point. Okay, I'm going to use this one, and since it's a vector 2, so I'm going to just new vector 2 here. You don't need to worry about vector 3. So vector, I think previously we used vector 2 or vector 3. Yeah, let's just leave a vector 2. Vector 2 delta. Vector 2 order is insufficient. Let's just not change it. Let's just use the vector 3 for now. Get the vector 2, and then yeah, let's not mess up other places. So we got this vector 2. Vector 2, and so the main camera will be so the starting point, as I said, as I draw earlier, the starting point will be 0 0. Okay, so it will be 0 0. Right, Copilot already know what I'm doing, and this will be our so the left and top down is the point, so it will be left is the bound, or then be a starting point bound or something like that. Yeah, let me just use the lowest bound. Okay, low bound. Low bound would be okay this one, and right now we haven't declared this low bound yet, so it can't resolve, and I'm going to declare it. And since it's a vector 2, your newer vector 2 here, I'm going to copy this low bound and declare it at the beginning of our code. We got a serious to fill here, and let's give you guys a vector 2 and say that will be a low bound. And of course, I can declare vector 2 and a high bound. And now we got the low bound of this and high bound. Let's Copilot do this work. So the high bound will be 1 1, which is good because I'm going to get this one. Okay, once you got the low bound and high bound, and that is according to the main camera. Remember, the boundary does not necessarily mean the hard boundary, but it's a soft boundary that only connected to this camera rather than anything else. So the word is still there. It's just that this object can't, this llama can't move out from your view. And so yeah, and then we already got this this boundary here, and let's fix our move. Okay, so we can right now we can transform to any places we want by using the delta, right? So let's just use vector 2 here, and so everything should be vector 2, yeah. And the delta will be user's input, so upside down, left and right, and move speed, and this will render frame in relevance, and yeah, and our yeah, let's add a vector 2 here as well. So our position will be transform position. Yeah, transform position translate. This translate will require a vector 3 delta. So let's go with the suggestion. Pos will be a pos will be our new vector 2. Okay. So after you have made a changes to the position, yeah, you need to climb that according to the boundary. So let's look at compiler suggestion. Positions x will be mass f climb. Climb means that you are going to cut it in a certain range, and transform position. So you actually move that as the x-axis plus the delta. So delta will be the change, like the delta in algebra. X and minimum x higher bound x. So yeah, so they will restrain that to x. So the x basically, yeah, I think this is a good one. I'm going to draw that for you. So basically, you got the x axis here, right? And when you say you place here and you press this position, you just move all the way here because you're going to transform the position of the player, and you climb it at this certain area, which means that you're going to climb at one on respective x-axis. If you don't worry about the y-axis, the only thing you need to worry about is the x-axis. So the x-axis, the climbing point will be starting at 0 and all the way up to 1. So it will just inside this range. And if you go left, even though say you transform to a minus the say 10 position, still you're being clamped at the minimum bound. That will be 0, right? So if you move to the right, you might get say 100 position, but doesn't matter. You're being clamped here, and only thing that you can transform would be just 1. So you clamp to the x-axis, and of course you can also just clamp this y-axis, and I think yeah, it will just automatically generate the y-axis, the lower bound, higher bound, and it will just fix it at these places here. And of course, after you have clamped the number, you can safely transform, because the new position will be just confined with the certain area. And yeah, so let's save it and go back to our game. And I got tons of projects working on, as you guys can see, and yeah, I nearly go crazy with all this project. And let's yeah, let's let it build, and let's run this script. Okay, so the right side, remember, is our game. So let's test this out by moving our llama. And okay, I run this app, and now I encounter a bug, which means that when you upside down, left and right, it does not move. So here is how I debug. I go back to my codes, and I realize that the bound, right, the boundaries was never called. So if you look at a method, boundaries never used. So yeah, so I have to use that, and let's think about this. This boundary need to be used, need to be called at the really start of this of this game. So how to do that? We can add a start void start, and say that let's just make simple, and let's say we're going to set this boundary at the very start of our game. So boundaries, I'm call that as very start of the game, and this error goes away. Let's go back to our game and see whether our llama can move or not. So wait for it and run reload script assemblies, and yeah, our llama can actually move. And the moment of truth, let's see whether the llama can move outside of the area. And yeah, the llama can't move outside the area, but I think his head can get outside the area. and left. Strangely, the llama can go left to the outside of the area. And let's see, check it down. Okay, the llama can't go down. So the left is a place where we should pay special attention to. We need to solve that. And left, right, we can't move to here. So I think I might know where the problem is. So the llama can only go left to left and see. I think maybe he will go to a point and then he will stuck. So yeah, so basically the llama still got a constraint, but it's not at the same camera as we expected. So yeah, let's dealing with that. Right, so I think I might know where the problem is, so just bear with me. So the player's position is not transformed. So if you double click this player and this llama, the position may be a little bit weird position because I move it a lot. So you can click and reset it into this original position. So if you look at the enemy, the enemy's position, Coyote's position, is a little bit weird. So you need to reset it so it becomes 0. Yeah. So and the enemy here, I think you need to reset it as well. So yeah, so you can go to this original position. And then let's test the llama. So hopefully it can work this time. The llama will start with the beginning with the center of the screen. Let's move it a little bit. Let's move this llama and hopefully it won't go outside of the boundary. Okay, let me see. Yeah, so right now the llama can't move outside of our boundary. That's pretty good. So we can actually move a little bit outside of the boundary. That's because the center point of the llama is at approximately the end of the neck area here. And yeah, let's our llama move to the right side. And let's see here. Right, so we stopped here. And yeah, I think that looks pretty good. So yeah, actually we got this boundary thing working, but I think I don't want this llama to move to the front like here, because if you look, if you move it here and say the enemy coming out and you instantly touch the enemy and may cause some discomfort for the player. So we don't want that. We want the llama to move, say, approximately to the left side. This is one thing. The second thing is that we don't want the llama to actually move his head out, and we don't want the llama to hide behind. So yeah, I think I might adding a restraint to like the offset of the position of the climate position, because the climate position is according to the camera's viewpoint, but you can offset a little bit so you can get a better restraint. So yeah, I think it's already a pretty long video. I'm going to solve this problem in the next video. Okay, so yeah, don't forget to subscribe to my channel and give this video a thumb up. Okay, bye.